Hi students, problem number 10. A conducting circular loop is placed in a uniform magnetic field 0.04 Tesla with its plane perpendicular to the magnetic field. So a circular coil is placed perpendicular to the magnetic field. Okay. Now the radius of the loop starts sinking. This is a new word for us. This is very new for you. The radius of the loop starts sinking means it is going to change. Radius is not fixed. It is also changing at some rate. So it starts sinking at a rate of 2 into 10 power minus 3 meter per second. The induced EMF in the loop has to be found when the radius is 2 centimeters. So when the radius is sinking, either expanding or shrinking, it is varying. So when it reaches the value 2 centimeter, what will be the EMF induced in the coil? Very brilliant question it is. And it cannot be understood that easily unless you read again and again. Okay students. Anyhow, first I will write whatever quantities are given in the problem. Now in this diagram you can see that the axis of the coil, okay, the normal drawn to the plane of the coil is along the field. Therefore theta is equal to 0 degree first. Next, what is the magnetic field? The value of the magnetic field is 0.04 Tesla. Then the radius is sinking at a rate. So d radius by dt, dr by dt is equal to 2 into 10 power minus 3. So this is 2 into 10 power minus 3 meter per second. But the EMF has to be determined at a radius equal to how much? 2 centimeters. So when the radius approaches the value 2 centimeter, that is 2 into 10 power minus 2 meter, what is to be found? The induced EMF E has to be found, is it not? So these values, first, are you all understanding? Then what next? We have to go stage by stage. Okay children, now the plane area of the coil is equal to pi into r square. Okay, pi r square. So let this be as it is, because it is a circular loop. I have taken area is equal to pi r square. Okay. Now the flux, okay, flux in the coil phi is equal to B vector dot product A vector. That is, phi is a scalar. This is equal to magnitude of B into magnitude of the area A into cos theta, cos 0. So cos 0 is equal to 1, is it not? So flux phi is now equal to, I have to substitute the value of B. What is B here? 0.04. So this is 0.04 into area as it is. Okay, as it is, I am going to substitute. So this is pi into r square. So this is the second step. So I told you students, this type of problem you have to remember step by step. So first we have to get an expression for the area of the circular loop. Second we have to get an expression for the magnetic flux linked with the circular loop. Then you know that according to Faraday's law of EM induction, the induced EMF is what? E is equal to minus of d phi by dt. Is it not? So now the induced EMF. The final step we have reached. Induced EMF in the coil is E is equal to magnitude of minus d phi by dt. So here we need only the magnitude. Okay. So I will write, therefore EMF is equal to d by dt of, what is phi here? Phi. So this is 0.04 pi r square. Okay, this is so the constants 0.04 pi, they can be taken out. So this is now equal to 0.04 pi into d by dt of r square. So this is equal to 0.04 into pi into d by dt of r square is 2r. okay, into dr, okay, 2r into dr by dt. Okay, now I will substitute the values. So this is equal to 0.04 into pi into 2 into what is the radius value, at what value of r we have to determine the EMF is 2 into 10 power minus 2. So in place of this r I am going to substitute 2 into 10 power minus 2. Okay, now what is the dr by dt? 2 into 10 power minus 3. So this is 2 into 10 to the power of minus 3. Very simple now. You see here, this 2 into 2 is 4. 4 into 2 is 8. 8 fours are 32. So 8 into 0.04 must be equal to what? This must be equal to 0.32. So I have multiplied 0.04 with 2 into 2 into 2. So 8 into 0.04 is 0.32. And here is one pi. So pi into 10 power how much? Minus 5. So this is a 10 power minus 5. Okay. So now I will multiply by 10 and I will make this power as minus 6. So this also can be written as what? 3.2 pi into 10 power minus 6 volt. So this is the EMF. So 0.32 I have multiplied by 10. So I have to divide by 10. So the power becomes 10 power minus 6. Okay. Therefore, the induced EMF is equal to 3.2 pi. 10 power minus 6 volt is nothing but microvolt. So this is the final answer. Okay. So which option you see here? A, B. Okay. B is found to be correct. 3.2 pi microvolt is coming. So option B, okay, option B is the correct answer. So this type of problem and all is new to us. In the regular class, your teachers must not have done such problems. It is a new type of situation. So for competitive exams sake, you have to get exposed to such new types of problems also. I hope you must have understood well. Fine.